it seems everyone's gotten the memo. Attendance is now going to be a little bit more enforced. So yeah, hopefully the in-class people are here, virtual people are where they need to be. And if you do need to attend virtually for any reason, then you have to let me know before class, and I have to approve your excuse in order to let you attend virtually for that period or number of weeks you are out. Additionally, if you don't come to class, of course, the link for the recorded video lecture will not be provided to you. So that's another thing to keep in mind. So with all of that out of the way, I suppose any other general announcements really refer to any upcoming assignments, which really all there is the quiz. So the quiz is going to be due tonight. So if you have not done the quiz yet, please make sure you do the quiz. Besides for that, if we finish the central tendency homework today, I'll make that due Wednesday. If not, pick another day for it. But that's the expectation going forwards. Does anyone have any questions for me before we start on the new material? Not? Then let's go ahead and do so. So we're on a new chapter, and this is numerically summarizing data. So in the previous chapter, we talked about how to organize the data, qualitative versus quantitative, how to represent this data, perhaps using a bar graph or histogram, things of this nature. How do we construct categories and intervals for these things? In what situations do we really do all these things? And so really what this chapter focuses on now is more of the analytical side of things. This is on the expectation that now you do have a little, you do have some model to work with, or you do have some sort of formulation of all the data you've gotten. You've organized it, maybe you put it in some sort of histogram, bar graph, and now that you've determined the shape of it, now we're going to analyze it a little bit more, try to see what the information is telling us. And probably the most simplistic form of doing so is by looking at a measure of central tendency. If you took Math 105 last semester, a lot of this stuff is going to come up again, but with maybe some different terms and maybe some different situations, but overall the ideas are predominantly the same. And so a measure of central tendency, as the name suggests, all that means is we're looking at what the center of the data does, what the expected value is to be. So a good example of this, generally in any class taught really at any university, the center or the most expected grade that students are to get is generally a C. Not saying that you're going to get a C in this class. It's not saying every class is situated like that, but when we try to generalize to the grand scheme of from past data, what does that tell us about a standard, say this class right now? What that tells me is that I would anticipate the majority of you in this class to get an average of a C grade. That may be wrong, it may be right. That just depends on how everything goes, but the measure of central tendency gives us an idea of how to analyze that data. And we have three measures of central tendency: the mean, the median, and the mode. These are all three different ways of measuring central tendency. And in some situations, one may be better to analyze than the other. And we'll talk about strategies for doing so. But in general, there's three of these, and we'll talk about them one by one. You probably are familiar with all of these as well, but I'll talk through them regardless. We'll start off with the mean. So the mean is it's the arithmetic average of the values. So this is where you would add up all the values and divide by the number of values you added up. And we do have two different types of means, but they're computed the same exact way. The formulas are the same exact formulas, except we have different variables for what situations they refer to. The population mean, that's if you're finding the mean of a population. So if I happen to know the GPA of every person graduating from Southeastern, and I found the average of all of those GPAs, that would be a population mean. And generally, if you're finding the mean of a population, we use a Greek symbol. This Greek symbol, it looks like U, but it's the Greek letter mu. M-E-W is how it's pronounced. So it's the Greek letter mu. But the formula is going to be the exact same. The only difference between these two formulas is a stylistic change. This one uses a capital N. This one uses a lowercase n. In the first section, or the first chapter, we talked about how capital N is the number of values in a population, and lowercase n is the number of values in a sample. Which does lead us to, so that was the population mean, and then there's also the sample mean, which is probably what we're more so going to be focused on, the sample mean, even though they're both solved the same exact way. So don't get too clouded by that. The sample mean, it's X with a little bar on top. So it's got a little bar on top. And this is the mean of all the values in a sample. For some review on terminology, the population mean is a parameter. The sample mean is a statistic. This was some terminology we introduced towards the beginning of the class. Parameter is some sort of observation about the population, and the statistic is about the sample. Parameter, population, statistic, sample. I mentioned that alliteration. But regardless, computationally, the mean is going to be solved the way you think it would be solved. You add all the values together, you divide by the number of them. So I'm not going to focus too much on how to do the mean, and instead I'm going to look at some sort of modified example, which does take that formula and has us think a little bit. So let's just say I found the mean height of all, say there's 25 of you in here, that I figured out all of your heights. And I found this height to be 67 inches. I think that comes out to be a little under 5'6". 67 inches. And then I finish the study, and then, oh my goodness, Drew Brees walks in, and he wants to be part of the study. So Drew Brees is 72 inches tall. He's 6 foot exact. So we're going to figure out what's the new mean height. So example 1, I found the height of everyone in the class. I averaged all of that. We found it to be 67 inches. Drew Brees walks in, and we're going to include his height as well and see how that affects the new mean height. So for example 1, this requires a little bit of thinking, because example 1 assumes that, well, we're not going to have access to the 25 students' heights. What we did do, though, to sort of bring the formula above a little bit of context, we took, so the X1 would be the first person, X2 would be the second person, and then X with a, not a 17, X with a 25. So we took 25 students, we added all of their heights together, and then we divided that by 25. And so what we did, we found the average of that, and that came out to be 67.0. That was the first thing we did. What we need to find is what happens if we include Joubry's as well. We would take x1, x2, we'd add that to the 25th value. And then here's the Drew value. I don't know what it is. Actually, I do know what it is. So I can actually just plug that one in. We know that his height is 72.0. And now I'm dividing by 26 because we have a new value. So I'm dividing by 26. What is this equal to? We don't know. That's what we need to find out. So the question is, how do we figure out this problem if we don't even know the individual values? And that's where I'm going to pass it off to you all. How do we figure this out? Anyone think outside the box?
Multiply 67 by 25, and then add 72, and then divide by 26.
You're exactly right. Yeah, so notice, one of the misleading things about this problem, you don't need to know the individual values. You might think, well, how are we going to figure this out? Let's go back to a place and a time where algebra came into play. And in this class, we're only going to do the slightest amount of algebra. It doesn't come up much in this class. If it does, it's going to be very tame. On the left side, we're going to multiply both sides by 25. So this is times, this is times. It cancels over here. And what we get on the left side is x1 plus x2. Basically, if I added the first 25 values together, we're going to get 67 times 25. Probably a big number. So 1,675 inches. That would be the total number of inches for every student in the class. And you might think, well, how's that helpful? Well, guess where that number goes? That number goes right here. Notice we could just switch. We can completely just switch them out. So we don't need to know the individual values. The sum works perfectly fine. So I can take that underlined part in red because we know what that equals. That is 1675 plus 720, or 72.0 rather, divided by 26. Oh, and look at that. That's all numbers. (1675) plus 72 divided by 26. Make sure you put it in the calculator correctly. 67.19. That's what I get. And so that is the new mean height. Again, we didn't need to know any of the individual heights. We just needed to know what the original average was with the number of people. And that's all we needed to use. So there's a homework question fairly similar to this one. So this will give you an idea of how to proceed. Does anyone have any questions before I move on? Is anyone keeping up with the stock market as of lately? How's GameStop doing?
It doesn't matter now because they put a cap on it, right?
Depends on which brokerage you use. I don't know. Robinhood wouldn't let me get. I don't know. Robinhood's been fighting against me the whole time on it. So let's move on to the median. Another probably familiar measure of central tendency. So the median is the value, all that lies in the middle of an ascended list of values. So you put the values in order, the median's going to refer to the middle data value. So if the number of data values is odd, well, then the median's pretty easy to find. It is legitimately just the middle value. There's an odd number of data values. You just pick the middle one. And what is that middle one? The middle one's going to lie in the position that is n divided by 2. So if there's 20 samples, or that's even actually. So 19 divided by 2 is 18 divided by 2, 17. 19 divided by 2. So 19 divided by 2, let's use that example. 9.5, so gives you an idea about where the middle's at. 9 or 10, I can't think of which one's which right now. 1, 2, 3, 4, 5. 5 divided by 2, 2.5, so it'd be 3. So you just round up. Okay. You just round up. Now, if the number of data values is even, so I'll put 6 dots here, then you're not going to have a definitive middle value. You're going to really, in essence, you're going to have 2 middle values. And so what you need to do here is determine those 2 middle values, which are going to be in these 2 positions, and find their average. So again, this is probably stuff you've done before. I believe we did this in Math 105, but so you find the average between the 2 middle values. And then that's how you find the median. So again, with 6 divided by 2 is 3. So that would be the first position. And then that plus 1 is 4, which would be the second position. In fact, I got this out of the book, but I don't think that formula is the best. I think what would be better is n plus 1 divided by 2. That would do a much better job. N plus 1 divided by 2. So I changed my mind. That one doesn't require any rounding. That's for odd. But then again, we're going to see later that we're just going to use the calculator for everything. So it doesn't matter too much. But example 2 wouldn't really be too practical to use the calculator because this is a very specific situation that requires you to use some sort of formula somewhere. All right, so a GA, that's a graduate assistant. We don't generally have too many of those at Southeastern, but some teacher's assistant grades some homework for a stats class, and they figure out the median to be 73.5. Cool. They give the papers back to the professor. The professor notices, hey, one of these homeworks is missing. GA must have misplaced one of them when he figured out the median. So there was an even number of homeworks, so he had to have taken 2 of the papers, the 2 middle papers, and he knows that the other one was a 75.8. And the other homework is just gone. He doesn't know where he put it. So what was the missing homework grade? So that's what we need to figure out. So we know that the median, and the median, they'll normally use the letter, just capital M for the median. So the median, they told us that it's 73.5%. And the first homework, or one of the homeworks, is 75.8%. Homework 2, we don't know. But apparently, those two homeworks were the two middle values in an even number of homeworks. So that means if we work this out, what this graduate assistant did was they took the first homework, they added it to the second homework, because those are the two middle ones, and they found the average. So they divided it by 2, and that's how they got the median. Homework 1 and homework 2 are the middle values. So according to the definition, add those two together, and you divide by 2 to figure out the median. But we know the majority of these values. H1 is 75.8. And since all the values are parentheses, or not parentheses, percentages, we don't have to convert to decimal. We don't have any other values other than percentages. So for that reason, we don't have to convert. You can if you want, it'll work out the same way at the end. So 75.8 was one of the homeworks. We don't know the second homework, but whenever we took that sum and divided it by 2, all of a sudden we had 73.5. And notice this is algebra. This isn't the craziest algebraic situation, but whenever you're solving for a variable that's not by itself, that in essence is what algebra is. We got to solve for that value. So we multiply both sides by 2. So let's figure that one out. 75.8 plus H2 is equal to 73.5, so 147. 147, cool. Just subtract and we're done. Pretty simple stuff. Minus 75.8. And so that missing homework value was 71.2. So there's a few problems, or not too many, but there's a few problems that, as I already alluded to earlier, we do utilize the calculator for a lot of the larger data entry problems, but maybe one or two that you can't just simply put into a calculator. You have to think about it a little bit. And these would be situations of that. Oh, what can you see? Okay, any questions for me before we move on to the mode? So let's, if not, let's move on to the mode. And we have a nice little team building exercise here. So for those of you who want to, well, I want you to contribute to the study. So think about what answer you're going to give me for example 3. So go ahead and foreshadow that answer. And you're going to tell me whatever answer you feel comfortable telling me for example 3. So think about that one. The mode, though, for the time being, the mode is the most frequent one. This one should be the easiest one. Everyone occurs the most. That's the mode. There's no mode if every value occurs only once. So, but if there's a bunch of values that occur like the same amount of times and they're both most frequent, then we'll have multiple modes. So with example 3, we're going to build this one ourselves. To determine the amount of alcoholic beverages consumed by a Southeastern student, you know, none of you would ever drink underage, right? We determine the mean, the median, and the mode, the alcoholic beverages. So what I'm going to do is I'm going to list these off to the side first on another page, and then we'll bring it all back together. So whatever answer, you could tell the truth. I won't know if you don't tell the truth. But this is going to be how many alcoholic beverages have you consumed in the last week? And to break the ice, I had 5. So how many here? So I'll start off with the people in class. People virtual, go ahead and type whatever number you're going to tell me. Again, I don't really care how many you had. I was a student before. So how many people in here had 0? 1, 2, 3, 4, 5. Okay. 1, 2, 3, 4, 5. What about 1? 1, 2. 2. 3. 3.
Do blunts count?
What's that?
Do blunts count?
Blunts count? Yeah, throw it on. I don't care.
Sure.
Let's say a blunt's about an alcoholic beverage. Well, actually, that's a lot more, right? I don't know. Yes. About. I mean, just being pragmatic here. I don't smoke, but I figured that's a lot more than an alcoholic beverage. You can interpret it however you want. Freaking blunts. That caught me off guard. Funny though. How about 4? Anyone more than 4? Really, well, I guess I am 28. All right, so virtual people, go ahead and let me know. Oh, now I see why these people are virtual. Okay. 2, 4, 5. All right. Nobody else wants to contribute? I see there's more virtual people. Okay. It's 5 somewhere. It's 5. Okay. I like your honesty. All right. That's okay. Yeah. I'm just going to put 1 anyways. I mean, it's a different kind of semester. All right. That was awesome. So let's keep going from there. So now that I have all those values up, I'm going to list these in ascending order. So let's see, we have 5 zeros. 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5. Some 1s. I see 3 1s. 1, 2, 3. Bam, bam, bam. A couple of 2s. What's that? 1, 2, 3, 4 2s. 4 2s. Some 3s. 2. 4, and some 5s. So here's the number of values. And off to the side, might be helpful to put how many of these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. 17 people. So to figure out the mean, as you would imagine, is we add up all the values and then we divide by, well, how many values we had in total. So instead of putting 0 plus 0 plus 0, blah, 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 I'm just going to simplify this. 0 times 5 plus 1 times 3 plus 2 times 4 plus 3 times 2 plus 4 times 1 plus 5 times 2. If you add 0 to itself 5 times, it's 0 times 5. If you add 1 to itself 3 times, and so on and so forth. So it's the same thing. I'm just notating it a little bit more concisely. Divide that by 17. Let's figure out what we get. So 1 plus 8 plus 6 plus 4 plus 10. 29 divided by 17. Oh, 1.71. See, seems to be the average number of drinks. 1.71. Okay. The median. Well, to figure out the median, we need to figure out how many values there are. There's an odd number, so let's find the exact middle one. Instead of having to count which one the middle one is, we can figure out median is n. Actually, so since this is an odd number, it's going to be in the n plus 1 over 2 position. So 17 plus 1 over 2, of course, 18 divided by 2, 9. So whatever number's in the ninth position. 1, 2, 3, 4, 5, 6, 7, 8, 9. So the median is 2. Found the one in the ninth position. Okay, so we have the mean, we have the median, and what's the mode? What's that? Mode's the one that occurs the most frequently. It's 0. 0 is the one that occurs the most frequently. So the mean, median, and mode all give us, yes?
How did you get B? Because I have a total of 31 divided by 17.
Maybe I typed in something wrong. Let's find out. So let's see, 0 times 5 is 0, 1 times 3 is 3, 2 times 4 is 8, 3 times 2 is 6, 4 times 1 is 4, 5 times 2 is 10. Oh, it is 31. Where did I get 29 from? You're exactly right. I have no idea where I got 29 from. So let's try that again. 31 divided by 17, thank you. So yes, that's going to change slightly to 1.82. So if we make little mistakes like that, just let me know. It happens every now and again. All right, cool. Is that what everyone got? Okay, cool. So from there, there's also a question I ask below, and I'd rather summarize this with the data set in mind here. So I'm going to leave the data set. And the question I'm going to ask, do you think this data is skewed in any way? Remember that word I used last time in class. Do you think this data would be skewed? More so just an intuition, just looking at the data.
Would it be skewed left?
So why do you say skewed left?
Because the numbers, they rise from 0?
So the following thought process is right, but it's going to be skewed right. It's in the direction of the tail.
Oh,
there would be a tail on the right side, because on the left side, everything's going to be risen up. So it'd be skewed to the right. It's always in the direction of the tail. So this is going to be skewed to the right. So this is going to be skewed right. And this is, hopefully the case for a class of, I guess, morally, this is good for a class of people who are generally under 21. You would hope that it's skewed right, because if not, it means a lot of you do a lot of drinking, and you would want to drink under 21 when you're not supposed to, right? So this is skewed to the right. There is a tail on the right side. And this will make more sense. There's another alcohol example later on, and we'll see this in a little bit more detail, but we're going to establish a little bit more associations before we get there. There's a tail on the right side, which means that the left side of the values are much higher. Again, we'll see this again. We're going to see this again. This is just an intuitive perspective. Does anyone have any questions before we move on? If not, so this is skewed right, and there's one more thing I want to get out of this. Because of the skewed right nature, do you think the mean, the median, or the mode will be the best form of central tendency? Do you have any intuition?
Probably the median.
Probably the median. Why do you say the median?
Because 2 is pretty close. I feel like that'd be like close to the highest point, either 0 or 2.
So this is going to be the median, and I'll explain why later. I'll explain why later. It is going to be the median, though, as the best one. So the way I'll break it down for now, so in general, the mean or the median should be used when viewing quantitative data. And really, we only use the mode for qualitative data, because remember, qualitative data can't be added and subtracted and divided. So it wouldn't make any sense to find the average of those values. You can't find the average of people who answer their ethnic background on a survey. So, but you can add the age of college students, an average college student. So the mode is used for qualitative data, and the mean or median should be used for quantitative data. In the previous example, this is quantitative data, because you can add, so to 0 alcoholic beverages, you can add 2 to that and say, I had 2 more drinks than you did. Or I had a fun night and I had 5 more drinks than you did. But you can add or subtract to those. I mean, these are discrete quantitative values, but it's still the same idea. And so now we go a little bit further into what does it mean to choose the mean over the median? When should we choose one over the other? And what we're going to do is first define resistant data. Resistant data, if you had me for 105 when we got to the section on statistics, I called this as one value was more quantitative and one was more qualitative in terms of how it analyzed the data. Really, the terminology I was dancing around was resistant. What it means for a summary to be resistant is if you add extreme values on the top or on the bottom, it's not going to affect that measure too much. And so a very good example of this, if we took all of our annual incomes and averaged those together, or we analyzed all of that together, but then we also included Jeff Bezos's income as well. Now, as you would imagine, if we average Jeff Bezos's income into all of ours, it's going to say that the mean, because the mean takes every value into consideration, is probably in the millions of dollars. And I don't know about you all, but I am not making $1 million each year. So the median, though, will really stay the same or maybe move up to the next value. The median is resistant. Median is resistant because you can add an extra extreme value and the median is not going to change much. Remember, the median is based off of the number of values, not the quality of the values. And the mean is not resistant because the mean cares about every single value. This means the measure most likely affected by, well, skewed data. But skewed data is going to be the mean. That means the mean is going to be a very poor representation of the average if you have skewed or extreme values. And I guess the other word for it, the more technical term, is an outlier, which we'll talk about actually probably next week. And we can kind of see the effects of that in the following figure here. This is always, in theory, what we want. This is a nice normal distribution, the bell shape, in other words. And you can see as the tail is introduced in the left or the right figure, I guess I'll just pick the right figure. This would be, so what I just highlighted here, that would be Jeff Bezos's income in comparison to all of ours. And notice how the mean, instead of being centered around the hump of the data, it's shifted all the way over here because it has to account for that mean. This is also why we say skewed right. Because notice the outliers on the right side. That's the best way I've thought about it. And notice the median is closer to the center in a graphical perspective. So that's why, or that's another way to visualize how extreme values may affect the mean. It pulls the mean away from the center because the mean has to account for every single value. And that's one way you can think about it. And this might help you answer a few homework questions as well. So keep those diagrams in mind. And really, I summarized it to this table. This table is also in your textbook as well. The mean is the center of gravity. It tries to take all the values into consideration and find that average. So you want to use the mean well, of course, when you have quantitative data and when you have nice symmetry in your distribution. If you don't have nice symmetry in your distribution, as in there's a skewed data value somewhere, that's when you use the median. That's the only difference. The mean, if everything is distributed nicely, and the median, if there's some extreme value somewhere. And then you just use the mode when you have qualitative data. Does anyone have any questions about this before we move on? pina colada. That's funny. All right, let's keep going. So suppose another class at Southeastern was surveyed, and they were asked how many alcoholic beverages they've consumed. And I went ahead and provided a frequency histogram of these recorded values. So as you can see, 15 people answered 0, 10 people answered 1. Looks like about 5 people, 2, and probably 2 people had 3, 1 person had 4, 1 person had 5. That's what it seems like. In the first question, it asks for example 4, describe the shape. The shape of this, if we were to give it a shape, we kind of trace the outlines like that. So when you describe the shape, you explain, is this symmetric, skewed left, or skewed right? It's skewed right because there's a right tail. There's a right tail right there. So this is skewed right. So based off of the shape, based off of the shape of this, how do you expect the mean to compare to the median? So not which one do you trust more. This is part B is merely asking, do you think the mean is going to be larger than the median, about the same as the median, or smaller than the median?
The mean is gonna be larger.
What's that?
The mean is gonna be larger,
And why do you say that?
because it's gonna be closer to the scale.
You are correct, and that's a good way to think about it. The mean is going to be larger. Mean is going to be larger than the median. Or another, if you want to think about it in terms of symbolism, X bar is going to be greater than capital M. I think there's a homework question that uses that symbolism, so it means the same exact thing. So the reason why is because, exactly as you said, because there's a right tail, the mean is going to go closer to that tail, while the median is not going to be affected as much by those skewed values. Or if you want to just kind of memorize the situations, this was a right tail. If we scroll up just a little bit, what does a right tail tell us? Right tail tells us the mean's bigger than the median. So if you want to just memorize it, that's fine. But intuitively, that's the reason why the mean's going to be larger. The mean's going to follow the tail, the direction of the tail. And then for part C, which is also in relation to the shape, which measure of central tendency is more reliable?
The median,
Yeah, it's going to be the median because we have a skew. Whenever we have a skew, it's a good thing to trust the median.
It is more reliable when it's skewed in any direction.
Yeah, any direction, skewed left, skewed right. Now, if you have a double skew, then they're just going to cancel out and it'll just be the mean, but that doesn't happen too often. The skew messes up the mean though. It's going to give you a false idea of what the mean value is. And then part D is an interesting question. This doesn't have to do really with the shape, but with the setup of the study. Does this survey suffer from bias? So the survey I just asked you all, do you think that could be a biased survey? Not the sampling. So we're not asking about sampling bias. I'm thinking about survey bias. You think the numbers I got are going to be absolute? Why or why not? What's that? And that's the answer. Yes, this is going to be biased because people underage, especially, I'm looking at all of you. I mean, you were all very honest. That was great for my distribution. I was thinking everyone was going to say 0, thinking I'm, the police, but no, this survey definitely does suffer from bias. The survey suffers from bias because there's a response bias. Without the anonymous nature of it, you're less likely to tell me the truth. So this is response bias. Lack of, I'm going to spell this wrong, anonymity. I probably spelled that wrong. I'm looking it up. Oh God, that was way off. All right, let's try that again. Lack of that word. Anonymity. So many Y's in it. Okay, so yeah, that's pretty much it. Does anyone have any questions, or is that pretty straightforward? So that's why having graphs is so nice. It gives us a very strong sense of intuition towards interpreting the summary of data. But also that also relies on the process for which you use to analyze your data. Sometimes it's not clear what your categories may be or your classes. So if you make your classes too large or too small, then you might not even get an accurate sense of what the graph's trying to tell you. So this is stuff that statisticians have to think about all the time. They have to pick very specific regions and study them accordingly. That might even mean organizing the data in different ways to see which summary seems to be the most easily comprehensible. And so now, this is what I'm going to ask all of you to pull out your fancy TI 80-something calculators that you should have for this class. Because we're going to talk about how to do this in the calculator. It's a fairly simple process, and you can follow along with me. So I have one on the screen. So, and we'll work along with this example here. So let's say I asked you to find the mean and the median of this data, and there's a lot of data here. So you'd have to add all those up and divide by whatever. Once you get to a certain number of data values, you don't want to have to do this by hand anymore, especially because we're in the 21st century. We want to utilize technology. So what we need to do here, what we're going to do here is utilize the TI 83 or whatever calculator you have and do all of that. And so I have all of that. If you took 105 last semester, you might know how to do this already. It's the same exact process. If not, I have it step by freaking step right in the notes, and I'm going to follow it word for word. Press stat. Stat is towards the top here. If you click on stat, see exactly the screen here. If you want to add a list of values, you press enter from there. So you're clicking on edit. You might see this screen, or you might have data values in the first column because you took 105 already. You can clear out a whole column. So I don't have this written down, so if you need to clear out something, actually I'll explain that at the end after I have some values. Explain that at the end. But we're going to go ahead and add the values by just putting in each number and pressing enter. So let's see what the values are. Okay, so 0, enter, and you'll see it populate like this. I'm going to go ahead and put all these in. I want you all to do the same to make sure you do it, even if you're confident you already can do it. Let's see, 35, another 35, 8, 15, 20, 25. Three, 5. So, put in all the values. And sometimes there might be a chance you type one of the values in incorrectly. There's probably a chance I did it somewhere. We're going to find out by comparing our answers at the end. So on a test, when you don't have that option, you need to be careful with your data entry. But what it says from there, you put in all the values. Press second in mode to just cancel out of it. So basically you're just going second and then going straight to the right, which should cancel right to the main screen. And then you're going to press stat again, okay? And move your cursor over to calc, okay? And you should see the screen. If you follow all these steps one by one, then you should be right here, no matter which calculator you have. It shouldn't change too much at this point. And so from here, there's one variable statistics. That's what it represents. And guess what it's going to do? It's going to tell you everything. So depending on what calculator you have, it might be more or less steps, but you're going to keep pressing enter until all of this comes up. On your calculator, I believe on that calculator, the kind of fancier ones, you might have to press enter a few more times. Yeah, it's going to be 3 or 4 times. It'll ask you some extra stuff. Just keep pressing enter until you get this screen. Once you do that, you have successfully determined the one variable statistics for this data set. And keep pressing enter until you obtain the following values. So again, whatever calculator you have, you might have to press it a few more times. It'll ask you frequency list and other stuff. I don't know, but you should get this. And then you can move your cursor down to see all the values. So you should be able to move it down, move it up, and you should see everything. And we're going to be utilizing this really the whole class. There's a lot of very interesting data values here. So by making this something a process you're familiar with, this is going to come up again and again and again, because all these values we're going to use again and again and again. But we're only concerned with 2 for now. And I wrote this at the bottom. Oops. The sample mean is X with the bar. That's the very first one. The very first one. And the median, I have to scroll down a little bit for the median. Just MED, obviously. So we have the mean. And I already wrote it out here. I'll write it out again. X bar is 22. Median is 25. Unless I typed it in wrong. Did anyone get those answers? All right, I'm seeing a lot of head shaking yes, which means I believe I typed it incorrectly. If you did not get that, probably typed in a value wrong. Happens all the time. If you were in 105, there was one problem that had you type in 40-something values, something about a basketball game. Remember that problem? That one, the majority of people who got it wrong were people who typed it in one value wrong or typed in an extra value. Does anyone have any questions up to this point? Another problem. If not, let's go ahead and look at sample 6. So let's say the following data represents exam scores in a Math 105 class taught before COVID and after COVID. Let's see how COVID has affected a class that may or may not be mine, or classes that may or may not be mine. So before COVID, after COVID. So really just values stated just clearly like this. Analyzing that is going to be a little bit more difficult. And so that's why we want to figure out the mean, median, and mode to give us some sort of concrete interpretation of just some collection of data. You could feel like one is better than the other, but let's actually prove it. So some of you, maybe the left half of the class put in the first before COVID, right half of the class put in after COVID. Virtual people, do whatever you want. We're gonna make sure we get the right answer. Oh, also, I forgot to mention something. If you want to clear a data set that you had before, move your cursor up to highlight whatever the name of the list is, L1, and press clear and enter. And that clears the whole list for you. So clear, enter, that clears the list for you. And then you could just start over. I'll pick the top one. Those people not typing, you better have the right answer already because I'm going to call on you. For anyone who did the first list. Yes.
21 first.
What's that?
What answer do you want first?
The sample mean.
The mean is,
Did you do the first one or the second one?
first,
What'd you get for the mean?
73.552, 552.
Just 552?
Or
Did you get 55115385? Did anyone get that number? I could have typed something in wrong. Always happens. Did anyone get his answer? Closer to what I have? And let's just say it's 73.55. At least we can all agree on that. Did anyone not get 73.55? At least something around that ballpark. As for the specifics, I won't question it too much. And then who did the second one? You did the second one?
I got 66.24.
For the mean? We'll do kind of like this. So said 66.24. Did anyone else do the second list? Anyone at all? My non-typers, do you have calculators in your car?
Yeah, because I'm on at home.
Okay. What'd you get for the median for the second list? 4 point. Did you say a 1 or 4? 89? Okay, gotcha. Okay. So I'll go ahead and trust that these values are pretty spot on. They should be pretty close. I did this one last night. I think some of these look familiar. Okay, so top one, of course, is before COVID. Bottom one's after. Okay, so now we took a list of data and we've now quantified it to a mean and a median. So now we don't have to use intuition anymore. Now we have some concrete values here. And based off of these values, which class performed better? Yeah, the first one. The median in one is larger than the mean in the second one, but overall, in a direct comparison perspective, there is a clear, drop. So the before COVID class. And this gives an idea as to what that drop sort of looked like. So this is probably something the university is doing right now to see, can we keep facilitating this virtual, flipped, hybrid, all these different options of stuff, maybe for a math class. Does it work in different disciplines? Does it not work? This is probably stuff they're looking at actively and using stuff like this to figure out, well, what departments should we offer some more options to and which ones should we not? Which ones are working and which ones are not? You can think of this whole COVID thing as a very long case study that we're inadvertently thrown into, myself included. So suppose the value 6.92 is incorrectly recorded as 69.2 for the before COVID category. How does that affect the mean and the median? So thankfully I did the first one. So when I go back to my list, so it said the 6.92 value. Let's say that was, that should have been, or let's say it was incorrectly put as 69.2, like that. How does that affect things? So all I did was replace the number and just do the one variable statistics on it. So now it says that the sample mean is 75.95 and the median is something, 77.52. So what property of the median, what property of the median does this illustrate? So the median before was 77.52. Let's say you incorrectly mislabeled a value and the median stayed the same. What does that show about the median?
It's resistant.
It's resistant. Yes, it's resistant. The mean, though, was not resistant. And as I mentioned, the mean is not resistant because it was at 73.55 and now it's at 75.95. So it shows that the median is resistant. Does anyone have any questions up to this point? If not, there's one thing. Do you have to have a specific calculator? Yes, you have to have one of the TI-80 calculators, TI-83, TI-84, whichever one is fine by me. So the one you used in 105, if you took 105, to answer your question. So there's one thing I wanted to show everybody. Where's it at? Well, you do have an e-textbook for this class. So you don't really have to use the textbook except for, all right, hold on. Got 5 minutes, you're all okay. So you all have an e-textbook. Something interesting though, that I found. Towards the end of the first section, whichever page it's on, I think it was number 34. So just read 34 to yourselves. And then whenever you do, you're free to go. Not asking any question on it. You just got to read it and you're good to go. It's a messed up problem. It's just messed up. You can get out of here.